Okay, well, good evening, everybody. Thank you so much for being here. For those of you who don't know me, I'm Julie Brown. I'm the Executive Director for the Wentworth Watershed Association, and I am presenting the workshop that I actually presented the other day, about a week and a half ago for an audience of 50. And a lot of people we had 50 people in the audience, and there was a resounding request to have it available for streaming later and also for people who couldn't make it for a daytime workshop. So here we are. So my goal tonight is to kind of explain what cyanobacteria is and helping you all be able to understand what's happening on our lakes and in the lakes in New Hampshire and in general, and be able to identify blooms and know what to do if you see one and how to self-evaluate whether it's safe or not to go in the water. So um, it is just me here tonight. So if you have questions and I don't notice it pop up in the chat, please show yourself and unmute yourself and ask the question. This is for your information. So with that said, I will be starting. Let's see if this works. Should. Excellent. So cyanobacteria are naturally occurring organisms. They've been known to be in fossil record dating back over 2 million years, and they play a crucial role in our aquatic and terrestrial ecosystems and actually helping to establish um, our atmosphere. So previously, they were referred to as blue-green algae because of their color and superficial resemblance, and it's not actually an algae. It's somewhere between a bacteria and an algae. And yes, some of you who were in the health craze in the 80s, they were encouraging you to eat capsules of cyanobacteria. I'm not so sure that that was a great idea, but we learn more every year. We have scientists working in the field and learning about how things affect our bodies. Most of the press around cyanobacteria today is negative, citing all the horrendous neon-colored blooms that plague waterways and limit recreation. But billions of years ago, they laid the foundation of the development of the atmospheric conditions that support the diversity of life we see on Earth today. So they're not all bad, and they've always been around. Cyanobacteria are believed to be some of the earliest organisms and on the Earth, and obviously, if they help produce the atmosphere, they produce oxygen through photosynthesis. They thrive in some of the most extreme temperatures on Earth, from 150 degrees Fahrenheit in deserts and salt flats, and even are found in low temperatures in Antarctica. This, this adaptability highlights their ability to persist in diverse and harsh conditions. There are three main factors that help them grow. Obviously, they're photosynthetic. So if they're photosynthetic, they require sunlight. The temperature, their water temperature is ideally between 68 and 86 degrees Fahrenheit. And all of you who speak in Celsius, that's 20 to 30 degrees Celsius. And they require nutrients in order to flourish. The nutrients that we're going to be talking about today are either nitrogen or phosphorus. And in lakes, phosphorus is the primary nutrient that they utilize. So harmful algal blooms is exactly what you've been hearing about and are concerned about. The concern that we have, is not with all cyanobacteria itself, but with the ability of cyanobacteria to produce a bloom. Several different types of algae and bacteria can produce toxic, harmful algal blooms. Geez, those most associated with freshwater are dominated by cyanobacteria, examples like Microcystis, Gliotrichia, etc., which we're going to talk about in a minute. It's important to note that um, all HIABs, which are harmful algal blooms, are toxic, are not all harmful algal blooms are toxic. There's no way to tell if a bloom is toxic or not. So we have to assume that they're toxic while they're going on because there's no way to tell. There are quick toxin tests on the market, which I've been experimenting with over the past few years just to see if we can get some more information. But what we've discovered is they're relatively unreliable. They have false positives and false negatives, and therefore they're not really helpful in decision making. So some of the common species in our region and ones that I have seen and we have seen identified in Lake Wentworth and Crescent Lake over the past few years are shown up on your screen. Different species will be more dominant at different times of the year. It's difficult to tell without a microscope, but some have unique traits, like gliotrichia, which are the ones you can see with the naked eye, and they form those puff balls. So in terms of the species that you see on your screen, Microcystis, which is in the bottom left, is one of the most common and diverse cyanobacteria. It's known for its production of hepatotoxin and microcystins. The colony pointed out in the image represents around 500 cells. Because I'm sure you've heard a lot about cell counts, I wanted you to see when you look under a microscope that Microcystis is one of the smallest, and this little clump right here is counted as 500 cells. So when DES takes a sample and does a count, they're looking underneath the microscope, and they're determining what's there, and each colony will have a different assigned quantity of cells depending on its size and species. Gliotrichia, which we call glio, is generally estimated around 5,000 cells per colony. This is the gliotrichia, so this is a 5,000 cell colony. Cells are larger, that are larger. They kind of look like globs of cyanobacteria, and they come together and they protrude outward from the center of the vegetative cells. So these are the ones that you can see in usually late summer, and they're floating around, and they often look like a starry night as you're looking through the water column. Anabaena, which the species we have here is referred to as Delicaspermum, up here, their cells are usually arranged in filaments or chains and can be straight, spiraled, coiled, or spring-like, and are often described as beaded filaments. They also have specialized cells that are called heterocysts, and they're used for fixing nitrogen and regenerating cells for future colonies. When they coil up, they tend to be 250 cells in the count underneath a microscope, or when they're a straight line, like the one that says Anabaena, that's usually considered to be around 50 to 100 cells. This next one I have a horrible time saying, so please don't judge me. It's Warnachinia, and they are usually confused with Microcystis or Stelocepharium. Warnachinia is dense with around 500 cells on average. The cells are radial and tube-like and widely oval-shaped. Colony shapes are similar to that of pine pollen and can sometimes be confused. And they're blue and green to yellow color, and sometimes as they're ending their life cycle, they appear brown. So that one's a little bit more challenging. But just to give you an idea, when you grab a water sample of what we're looking for and how it's being counted. Okay, so why are we seeing harmful algal blooms more often? Scientists agree that they're becoming more increasingly common both in the US and worldwide. This rise is linked to human activities like agricultural runoff, urban development, and recreational pressures, which contribute to excess nutrients in the water, fueling the growth of these blooms. You know, if you've hung out with me at all in the past 8 years, that we spent a lot of time talking about stormwater. So when it rains, water picks up sediment, pollutants from impervious surfaces like rooftops, roads, yards, and carry it into the storm drains and ultimately into our lakes in a process known as runoff. During this time, nutrients from fertilizers, septic systems, or other sources are washed into the lakes, and this process is known as nutrient loading. Just like us, our lakes age too, and our lakes are aging. Excess nutrient loading accelerates the aging of lakes, causing them to deteriorate more quickly. This is what we refer to as cultural eutrophication. So if you see the humans are bringing in all of this excess nutrient loading, and also with climate change, which is causing the aging of lakes or the lessening of water quality much more quickly. So we have a big role to play in this, and we're the biggest part of the solution. Obviously, climate change is extending periods of warmer temperatures and creating ideal conditions for harmful algal blooms to occur and to occur in more abundantly. Um, so why am I saying climate change is significantly impacting our lakes? We are having more frequent extreme weather events that are leading to increased runoff and erosion. Excuse me. Introducing a lot more pollutants and phosphorus-rich sediment into the water, and really strong storms and flooding, like the 100 or 500-year storms we've seen over the past couple years, have led to rapid erosion. And with high water levels coming into yards and roads, even more pollutants can be swept up and from fertilizers, lawns, gardens, road fill, wastes, camp roads, etc. So all of that is getting washed in more quickly and at larger numbers during those big storms. Warming temperatures also affect the stratification of lakes. During the summer, the lake forms distinct layers, a warm surface layer, which is where we all like to swim, a cooler middle layer, and then the cold, dark bottom layer. Normally, lakes like Lake Wentworth undergo turnover twice a year because of their depth. In the fall and spring, when cooler temperatures allow the lake to mix, they redistribute the oxygen and nutrients. However, with warmer temperatures potentially extending that stratification period of when it's historically has been stratified, this natural mixing is delayed and it further increases the risk of harmful algal blooms and stressing aquatic life. One of the reasons we tend to see an increase in HABs or in the summer and the spring and now shifting into the fall is because of the nutrient availability with the turnover. So all those nutrients from the bottom come up to the top and then they're utilized, sucked up by cyanobacteria, and then they create more. Just like if you were to add fertilizer to your house plants, we're adding fertilizer into the lakes and then they're blooming. The one last thing to mention is that we've had shifts. This year was a decent year for ice in and ice out, but the past the ice in and ice out time periods are getting smaller and smaller. So what are we doing about it? WWA, Wentworth Watershed Association, partners with UNH Cooperative Extension to take part in the Lay Lakes Monitoring Program. And I think we may even have some of our monitors on this call today. So this graph that I have up here shows the overall trend in total phosphorus lake-wide since the monitoring program began in 1980. So the recent uptick in the past few years can be seen in Wentworth, while Crescent Lake has been climbing steadily. So if you look at the phosphorus on this graph, which is the median phosphorus is in green, and this is for Lake Wentworth, and they're two separate charts if you can see them. So you can kind of see as we are charting and testing the total phosphorus has kind of been going up and down, but there's a general trend upwards. And then with that, the median dissolved color, which means how much, if you're looking at that Seki dish that looks like a dinner plate down through the water column, what does the water look like and how tannin or how much life is in it and how much can you see? And so you can see kind of how that trend coincides exactly with how much phosphorus we're seeing. And that would be because of all the different growth. Not all growth is cyanobacteria, obviously. There's other plankton, other things that are floating around in the lake, chlorophyll A, etc. But this is what we're seeing with trends. So we've only really been tracking and learning about the species of cyanobacteria in our lakes and monitoring blooms since 2021. We started talking about it in 2019, 2018 at our water summit, but we've really been monitoring it and learning more. And so this is an ever emerging science right now. Although it is clear that blooms of glio in the late summer have been common in the lake for decades. I've talked to many people who've been here their whole lives and talked about, oh yeah, we've always had this snowy stuff in August along the beach. It has become more prevalent and stayed around for longer and in larger numbers in the past 5, 6 years. As lake science progresses and staff and volunteers and lake residents and visitors become more educated, the more we know about the blooms. When there is a reported bloom, DES and the Wentworth Watershed Association collect samples so we can learn more about what species are present and keep people informed about the water recreation safety and track what's happening in our lakes. So if you can see the number of days we were under warnings and watches over the past 4 years on this chart, um, gives you an idea of what's been happening. So let's briefly talk about how cyanobacteria blooms move, because it's not always where you see them that they started. Um, they move, they move around the lake and it's constantly changing. So I get a lot of phone calls saying, well, where was it reported? Am I safe on this part of the lake? And my answer is, well, what does it look like? Because it's going to move around. Wind and wave actions are some of the biggest drivers of bloom movement and also nutrient loading. So cyanobacteria are tiny, lightweight cells, and they float really easily, especially when they form a surface scum. Terrible word, but true. It's that film on the surface. As a result, even light winds can push these blooms across the surface of lake, causing them to accumulate in coves or along shorelines. So it may be at Wentworth Estates in the morning, and as the wind starts pushing, you might see it all the way down by Jean's Beach, and it just depends on which way the wind is blowing. Um, so just because if you see it in a certain area, it doesn't mean it's being caused by something local, like a failing septic system or nearby fertilizer use. That wind and water movement can often carry blooms from one part of the lake to the other. So the reason I want to point that out is not the blame game. We're all in this together. Boating activity can also play a role. Large wakes, the wake boats that have propellers that are disturbing things in the bottom or eroding shoreline and near shore boating can resuspend benthic meaning cyanobacteria on the ground. There's species of that as well. And then they break up patches of a bloom and spread them across to new areas. In some case, this movement can also mix nutrients back into the water column, which again will cause more growth. Beyond physical movement, some cyanobacteria species can regulate their own position in the water using specialized cells. So just like fish can move up and down the water column with their swim bladders, a lot of different species of the cyanobacteria have a gas vesicle, which is a tiny air-filled structure that keeps them able to have control of buoyancy, so they can move up and down. So just like you'd see in any of the ocean documentaries, you see that there's migration up and down in the water column throughout the day and night. The same thing happens in lakes. So they tend to rise to the surface during the day to access sunlight for photosynthesis and sink deeper into the water at night to access nutrients. So species like Gliotrichia and Microcystis are especially known for this kind of vertical migration. So a bloom isn't static. It moves with weather, reacts to boat traffic, and in some cases adjusts its own position in the water column. This can make monitoring it really challenging, and it's why reports from the public are so valuable in tracking bloom locations in real time. Because I might get in a car and drive all the way over to Pleasant Valley Road, and by the time I get there, the bloom's gone. And then someone's calling me over from Wentworth Park, and I'm like, take a sample, take a picture. And that's what we're going to talk about. So before we wrap up on blooms, it's important to talk about a few things that are often mistaken for cyanobacteria, especially by shoreline where residents or lake users are seeing something unusual in the water. The number one thing that we just got through wasn't that bad of a pine pollen year from what I was hearing, but pollen is one of it shows up in late spring and it often floats in large yellow patches on the surface. It has a dusty or grainy texture and it doesn't easily mix in the water. It usually stays floating even if you stir it. like with a stick. It's totally natural and not harmful, but can look a lot like a bloom. So in the top right-hand corner, you can see it. Green filamentous algae, this is not cyanobacteria, though it sometimes can coexist with it. It's stringy, hairy, cotton candy looking stuff. Um, you often see it on rocks, docks, or along the shoreline, and it can feel really slimy or fuzzy, and it tends to cling to submerged surfaces. Again, this is different from a bloom, but it can sometimes trap or hide benthic cyanobacteria, which is why we keep an eye on that one too. Duckweed is another common one. These are tiny floating green leaves like miniature lily pads. They don't discolor the water and they're not harmful, but from a distance they can sometimes look like scummy patches, especially when they're clustered. So that would be in areas you might see that in some of the small shallow coves or at the mouth of a tributary or those little alcoves throughout the lake. Iron bacteria is one that people are often worried about, and it creates an oily rainbow colored sheen on the water. I've gotten calls of oil spills before, and it's not. So often when rusty orange or reddish brown tones to it, you often see it near wetland outlets, culverts, or drain areas, and it may smell a little metallic-y or swampy. And while it looks like pollution, it actually is caused by a natural occurring bacteria reacting with the iron in the soil. So lastly, the dynamo, also known as rock snot, you're welcome, forms thick, fibrous mats that look white, tan, or brown. And it has a unique texture, kind of like wet wool, and it clings tightly to rocks and submerged surfaces. So this is not cyanobacteria.
Never seen. I don't think I
So
know.
how do you know the difference? This is photos taken from one of our water quality leadership team members who started as a water quality tester, Jim Connors, and this was happening a couple weeks ago over in Devil's Cove on Crescent Lake, and this is what we're talking about when you see that kind of bubbly green mass. And we ask that if you are concerned about it, this looks kind of fishy. A way you can tell is you can take a stick, just a regular stick with bark on it from the shore, and you can run it through it. And if you pull it up and it's got stuff dangling from it, it is green filamentous algae. It's also caused, overgrowth of this algae is also not great and is caused by the same excess nutrients that we've been talking about, but it's not harmful. But we keep an eye on it because it can coexist with cyanobacteria. But if the stick comes up clean, if you see a mass like this and you put a stick through it and there's nothing hanging from it, stay out and then you report it. Does that make sense? Everybody with me?
Yep.
Okay. That's what we call the stick test. So when you call in, you're like, I've got this green thing. I'm like, well, do the stick test. This is what we mean.
If it comes up with something.
See that stuff on the
Okay.
That's
Cyanobacteria are becoming an issue in many water bodies. Some of these photos come from neighboring water bodies and the larger watershed that the Wentworth Crescent is a part of. Education and action to address the root causes needs to happen everywhere as a group effort because what happens upstream or upland still impacts tributaries and lakes. Our watershed as well as the larger watershed. You know that all of our water ends up in the Merrimack River. So our nice clean water goes right on down. It goes to Lake Winnipesaukee, and then it heads out Lake Winnipesaukee and continues down to the Merrimack River. So everything we do here affects our neighbors and vice versa. So cyanobacteria move through wind, wave action. They don't hitchhike the same as other aquatic invasive species that they talk about is lake hosts. If you've been in a lake that has cyanobacteria, we're not asking you to clean, drain, and dry your boat on behalf of cyanobacteria, but we are asking you to do that on behalf of some of the hitchhikers that we have, like variable milfoil, and we definitely do not want the water fleas. They're coming our way. So there's a lot of other aquatic species that we're not talking about today, but cyanobacteria do not transport from lake to lake. Okay, so let's talk about the most important thing. So when in doubt, stay out. So we did this is the wrong information. Yeah. Okay, so if you happen to get in contact with something that, or your dog's in contact with cyanobacteria and you're concerned about it, you're looking for skin irritation, gastrointestinal issues. It can cause neurological effects and liver damage. So unfortunately, if your animal or wildlife consumes cyanobacteria or gets it in their body, there's nothing that a vet can do to stop its effects, which is why it's really, really catastrophic to the liver, and lots of pets have died around the country from it. So if there is scummy looking water, do not let your pet in the water, which I know is really hard to do. Similarly, um, kids, people who have health conditions, and pets are a higher risk of having side effects from cyanobacteria, but kids specifically and pets because they tend to be the ones who might actually slurp the water. Um, so again, if it looks like you don't want to swim in it, don't let anybody swim in it. So the state, there's a big change this year with the state. We feel like everybody's been pretty well informed, but what they're going to do is post general information about whether it's safe to swim in the water. So to do a self-assessment. So they won't be posting warning notices at public access points this year. Instead, there will be an evergreen information about when in doubt, stay out, and it will refer people to their Healthy Swimmer app to check to see if their water body is under a bloom or watch. So WWA will also be in contact with them. If there's been reports, they contact us. We go back and forth. Sometimes I run out and collect a sample. They pick it up at our office. I ask somebody else who's willing to collect the sample so DES can pick it up. Once they've evaluated it, they send us information, and then we blast it out as soon as we know. So when DES comes out and looks at it and collects a suspicious sample, we will get a notice of the warning. It's important to note that DES and Wentworth Watershed Association staff do not process or investigate blooms on the weekends. This is our job, but we have weekends off. So that is why it's important to look before you leap. So even if you call it in, you make the report, they're not going to send somebody out. So again, people tend to show up on the weekends, so always do a self-assessment. It is very important to note that it is never safe to drink lake water that you draw from the lake. You should use town water or bottled water for cooking and drinking. I know that many of you may say, well, we've been doing it for years. We're fine. Well, things have changed and we know more, and it doesn't mean that it's a good idea to do it. So bleach and boiling do not remove potential toxins. In fact, it causes cyanobacteria that may be carrying toxins within it. When the cyanobacteria dies with heat or bleach, it releases the toxins, so it actually amplifies the toxins. So it is not safe to drink the lake that's on lake water that's untreated. I do have fact sheets about all the different types of systems that people have been sold thinking that they can process the lake water. And in general, what it says is do not self-treat lake water for consumption. Okay, so what if I already did? What happens if you already went for a swim or somebody's been exposed? The things to do would be obviously to wash and clean yourself immediately with soap, monitor symptoms, and seek medical attention if necessary. If you have symptoms or are ill or you have a deceased pet, please report your exposure and health implications to DES. The more we know, the more we can do and keep everybody informed and prioritize prevention and funding for impaired lakes. So I'm not trying to be doom and gloomy, but I want you to know kind of what you should do and what you need to know to keep yourselves and your families and your pets safe. So How can you help? This is the help part. Look before you leap and always perform a visual inspection before you get into the water. If you see anything that looks suspicious, report the bloom through New Hampshire Department of Environmental Services through their Bloom Watch form, which I'm going to show you how to do it because it's really easy. After alerting DES, call or email us so we can keep an eye on the situation. And you can sign up for alerts on the DES website. So for certain water bodies, so if you recreate on Lake Wentworth or on Crescent Lake or Lake Winnipesaukee as well, you can request alerts. And if they change the status, you will receive an email directly from them saying there's an alert for that lake. So let's talk about what this looks like. So you're going to be asked to take a few photos, record the location, day, and time, and send the information on to us using their form. And I'm going to walk you through what that form looks like. So you put this is on your phone, your mobile device. We all have everything we need. All of us carry these things around with us too much as it is. So if you see something suspicious, go to the Bloom Watch form. You put in the date and then the location of where you are. It's going to ask for the water body name and where the bloom's located, and then location details. So you could say, I saw it out by Stamp Act Island by North Beach on Lake Wentworth. They're going to ask what your vantage point is. Are you standing on the shore or did you see it while you were boating? And then really importantly, what percentage of the water body are you able to observe from that point approximately to give you an idea of how much you can see? So if I was standing over on one side of Stamp Act Island, I could only see 45% of the lake because the other half I can't see. It's going to ask the size of the bloom. This is pretty important. I can't see the writing. It's time for glasses. Middle age is really getting me. Sorry. So you can see there's 5% or less, or between 5% and 25%, between 25 and 50%, etc. So then they're going to ask you, how does the bloom appear? Is it a surface scum? What does that look like? Is it up and down throughout the water column? It's just a simple questions that you should be able to answer. And then they have an image disclosure because if you share the image, then they have the right to replicate the image to share with people who for concern. So please do allow them photo privileges. And then they're going to ask you to take a couple of photos. They want a close-up picture of a bloom, and they even show you an example. And you take a picture. You can just push the button that has the camera, and it'll use up your camera, or you can have taken a picture on your phone with geolocation turned on. Most of it's already turned on your settings if you've never turned it off. And then you just upload it right there into that spot. And then they're going to want a photo that is from further away so they can get an idea of how far it goes and what it looks like. They will use this to assess whether or not they think it looks like a bloom, the size of a bloom, and what level of response is required. And then you can show them any description. So if you do a stick test or something and you want to put in that there's a lot of green filamentous algae present, or you did the stick test and it clearly wasn't green filamentous algae because you've taken this, you've hung out with me tonight and learned from me what that is, then their first thing they're going to do if they call you is they're going to say, well, you do the stick test. You can say, I've already done the stick test. That's why I reported this. They're going to ask your name, your phone number, and your email, and whether or not there's currently a warning on the water body. This is important because of the way the system has changed this year. You may want to report it even when we know there's already a warning on the lake. And I'll tell you why. So this has changed a little bit. from last year to this year, as we're learning more about how to inform the public, a warning is issued on a water body when samples exceed 70,000 cells at multiple locations. So more than one location, which is very different from last year. So if, say, there's cyanobacteria over by Jerry's house, and he reported it, and they actually came out and collected it and counted it, but then Skip said, oh, they've already been reported, so I'm not going to report it, and it's on his side of the lake too, they're not going to put it underneath a warning. So you need to report it as well, Skip, in this scenario, of course. So a watch may be issued based only on a photo when the cyanobacteria is clearly dense in the photos and is likely approaching 70,000 cells, but only one sample only one sample exceeds it, or the bloom material has passed. So use the healthy swimmer map to check out what's going on in the lake. So if you go do a sample and you see that that there's already a warning or watch, it doesn't mean you shouldn't report it. You should still report it. So NHDES will remove a watch after 1 week unless further reports occur. So watches can then escalate into warnings. So the good news part of it, I guess, now you know how to identify it, what's going to happen if you do, how to report it, what you're watching for, what the health effects are, all that doom and gloom things. But what are we doing to deal with it? So it's consistent with the work was started long before I arrived and hopefully will continue long after we all leave the area. We are working to combat risks and a number of occurrences of cyanobacteria by conserving land to protect water quality. We're updating our watershed management plan, which I'm talking about at the Water Summit this week. So hopefully you'll come, not me, actually, our environmental engineer is. Why are we updating it? It's to help us understand the most impactful steps we can take within the current conditions, land use conditions, to protect water quality, including stormwater infiltration projects, changing municipal ordinances, and all of the things that are recommended or coming out of that will help drive our work for the next 10 years. We encourage homeowners to pump and inspect their septic systems, remove pet waste immediately from properties, public and private. Encourage no fertilized usage. New Hampshire soils are known for being high in phosphorus naturally. You typically do not need to add it, and you can test your soil, but it's illegal to put any sort of fertilizer within 25 feet of the water. Detergents and soaps, like laundry detergent, have phosphates in them when they enter into your septic system. They leach out and actually create more phosphorus going into the water. So use natural products if you can. Shoreline revegetation projects like our plant sales we're having and working with landscaping in the watershed flyers and specialists, and we're hosting a workshop about how you can very easily revegetate shoreline. And so we're working on all these practices. We're working with the town to help reduce winter salting and helping people with their roads. All of the work we do reduces the loading, the sedimentation, and the nutrients. And everything that anybody does on their property can actually help make a big difference. Every little thing counts and they add up. So, Cyanobacteria 101. I hope that this was helpful. And now I hadn't seen anybody raise their hand. I am open and available for questions.
Can I ask a question?
Please.
Okay, I have a comment and a question.
Sure.
My first comment is on your stick test slide.
Yes.
You'll give extra points for anybody that sees the huge milfoil bloom that's right behind the stick.
You want me to show it?
Yeah, go to
I'm gonna
that
go back to
slide.
it 1 second.
Yeah.
Let's see. I'm gonna rush back through them. Close your eyes so you don't get nauseous. There we go. All right.
Go open that slide up.
I can't get closer to it in presentation mode, but I can see it skip over here.
Yeah, right above the stick. You can see it right where just right of the globule. There's a couple of nice tendrils going right out there, almost hitting the surface. It's ripe for harvesting, Julie.
I know, and I know exactly. I bet you've already gotten that piece.
But perhaps we've been there once this year, and we'll be there again next weekend.
Thank you, dive team. Thank you, weed watchers.
So my
Skip. Yeah.
question, fascinating about geotrichia going up and down in the water column, being suspended in the water column. So if we see it in the area where we're swimming, but it's fairly dispersed in the water,
Yes.
we would take a sample, and I presume we would take a mason jar.
Yeah, this is the part I missed. You did a really good job pointing this out.
Oh.
So
so I didn't miss something.
No, I missed saying it.
Okay,
So,
go ahead and say it then.
okay, so if the gliotrichia looks kind of like a starry night in the water, like you're looking down, you're like, oh, there's like a little smattering of snow pieces up and down, and it looks like that. It's probably just fine. It's so if you can look in the cup, the rounded cup, that's when you scoop the water up.
Mhm.
That amount is not going to be at the 70,000 cell count. So if you pick up a mason jar, we also have some plastic jars that you can borrow from here to bring us samples, but that amount is not going to equate to 70,000 cells because when we actually do cell counts, I've learned how to do them just starting to in the scientific way that they would do it for counts for DES. They mix up a water sample, they take a dropper from a mixed up sample, whatever they get in that dropper, they put onto a specific slide and then they count a gridded slide, and that is what they count. And you're not going to slurp up. If each of those little dots is worth 5,000 cells, they're not going to slurp up enough to have it be a true bloom. Now, if you look at the one above from Winter Harbor in 2018, if you were to do a slurp of that particular sample, you can imagine that it would be at higher counts. And so we like to say if it looks like the Milky Way galaxy, for all you stargazers, if it looks super dense, that is concerning. And then if it looks more kind of just starry, it's not as concerning. It's worth watching. It can change.
So I guess I go back to the round glass, and see the very light dispersion. We would not have children swimming in that?
So only you can make that decision. I do not want
It's
the
like only you
liability
can
for
prevent
that, but
forest fires.
I would say with that, I would say I personally may go for a swim in that. But I'm not pregnant. I don't have a health condition. I'm not going to drink the water, and I am always going to shower after I get out of the lake because I have the most sensitive skin in the world.
Well, and I think you made a good point that either kids and or pets, when they're in the water, tend to consume a lot more than adults do.
Right. So, but the other thing is gliotrichia moves up and down and it shifts so quickly. What I might do if this little area that that looks dense right here next to the cup, the gliotrichia picture, I probably wouldn't swim on that particular beach. I might kayak out or go further out into the water, go for a swim where I don't see it in high numbers, just cautionarily. But each of you has to make your own decisions.
Yeah, that makes total sense. Thank you.
Yeah,
Can you hear me?
I can hear you
Julie?
perfectly, Christine.
Okay.
I can take off my glasses now. I'm not reading.
Oh, wow, they're 10 years younger.
Thank you.
Um, for many years, I can't remember how far back, we've been here 30, but I've noticed little balls of things,
Mm.
more so in the end of the summer, they sort of gather. And I've never thought that they were anything bad. I just figured they were some kind of plant matter or
Well,
whatever.
you were right. It was an algae, so
But it's the glio
yep.
trichia.
You can just call it glio. You can just call it glio.
Glio?
Yep. That's definitely glio. And yes, it's always been around, and
Okay,
is
so
becoming more prevalent.
and it's very, I mean, like, we've we've been told that the bad stuff is more like fairy dust, looks more like fairy dust in the
Yeah.
water, and it travels, but this other stuff, the glio trichia, it's like always there.
Okay. So
Here,
gliotrichia can become toxic. That's why it's what we call, there's a list called the Dirty Dozen of cyanobacteria that are known to be able to become toxic that are found in our lakes. The ones that I've shown you, these top 4 are the ones that we've had annual recordings of. Mostly we see Delicospernum in the spring, and that's the one that we have seen. It coincides with um, pet sickness and tends to coincide while the pollen is blooming. Pollen does add extra phosphorus into the environment, but it's not the culprit. It's just another thing that's feeding it. But it it can be underneath the pollen. So if the pollen looks really green, not yellow, you may want to grab a sample, and that's the one that we've seen um, that I've seen since I've been here been the one that's been the culprit of toxicity, but microcystis is also toxic. Our gliotrichia, we have not yet seen it become toxic, but that doesn't mean it cannot or will not. We've done
okay,
some serious testing for DNA, trying to figure things out. We're doing behind the scenes science, but I cannot tell you that it is or is not toxic. You need to make a self-assessment and make a good decision.
okay. And which one do you know what I'm talking about when I say like the fairy dusts stuff?
Well,
It's
so
really
no.
fine in color, almost pretty.
So if it's
Um,
greenish, is it green
uh, I
along the
wouldn't,
surface or in the water column?
it's kind of along the surface, and it's the one that we've seen, it'll travel. It'll come into we're on Winnipesaukee and Jockey Cove,
Yep.
but it'll come in, and then it'll go under the dock and move away, within an hour or so, usually if there's a breeze. But
It
it
looks like a
looks,
mat. It's on top of the water. It's a surface scum.
yeah, I mean, but it's very pretty. It's like,
It's like
it,
luring you in.
it's very ethereal and sort of, it looks like somebody sprinkled fairy dust. And we were
Yeah,
told that was the bad stuff. Is
yes,
that
I would
true?
think that, yes, I would say that that would be accurate. That if it's floating on the surface and it's not pollen, remember
No.
pollen can't be like if you
Yeah,
stir it, it doesn't mix well.
right. We know
The
that. Yeah.
Delicospernum is kind of like a green. When this is the close-up that I'm showing you, this is like under a microscope.
But
But when you are,
can you see it
you can see it, but you
with
can't
your
see the
eyes?
individual cells. So
Okay.
if I go forward to, and this is the microcystis bloom, you can see kind of looks like this green surface scum. Over here, you can see this kind of scummy area. And this is on Yellowstone, so it's all over the place. This is Governor's Island on Lake Wempasaki. This is all either microcystis or it is Delicospernum. And this is, I don't know if this is what you're referring to as a fairy dust kind of magical, but that's kind of what it looks like.
Okay. Yeah, it's a little hard to see.
I've never seen it that thick.
Well,
Yeah.
that's good.
Yeah.
Yeah.
I mean, these are obvious photos that we use to point out that it can look slightly different everywhere. But I mean, I don't know about you, but I've been a lake recreator, I'm an ocean swimmer, I love the water. But if I come to water that looks anything like any of these situations, I am not going to get in.
Yeah.
It just doesn't make sense, especially if
Right.
there's dead fish.
Yeah.
But,
Mhm.
sometimes it's lake wide like these.
Can you go back to the one that has all the different names? The six?
Yes. That one.
Okay, thank you. I'll take a picture of it. Get the names.
And I have fact sheets on our website. I have fact sheets. I have in-depth information. You can go down a rabbit hole. I've been capturing information for years, putting the science from DES, Vermont, from our friends in Michigan. I've gone to the North American Lake Association Managers Conference a couple times, one in Minnesota, one in Vermont. We all share information and all of the most current research and information that we can get our hands on. I try to put the stuff that's most relevant on our website.
So Julie,
Yep.
I'm taking a sample. I'm gonna bring it in so that you're gonna identify it as geotrichia or not geotrichia. Hey, I put it in my mason jar? I cap the mason jar. Do I put it in the refrigerator? Do I leave it out on the
You're so smart.
counter? I mean, do I put it in a hot car? I mean, where should I put it?
That's a great question.
I don't know what to do with it, Julie.
So typically what you don't need to grab a sample until you've taken pictures. And once the pictures have gone in and DES says, yes, we want to sample that, or if you have taken pictures and you've heard nothing from DES and you haven't heard anything from me and you feel confident, you can always put on a glove, or you can go without a glove if you feel comfortable. Scoop it up with a mason jar, put a cap on it. If you're not coming straight to the office to bring it to me, you can put it in a refrigerator, and then bring it in. Within a couple of days, the sample becomes de facto. So don't grab a sample and keep it for a week and bring it to me. That's
It
not going to
doesn't,
help anybody.
it doesn't age well.
It does not age well. The cells desiccate. Yep.
Where
Oh.
is your office, Julie?
Oh, our office is over across from Back Bay Rehab. We're in the 51 Mill Street Plum, like
On-
professional plaza
on the-
all the way at the end. So past Mill Street Meat Market on the right.
Okay.
You know what I'm talking about?
Are you in the same building as the meat market?
No, we're in like, you know where the boat, there's the boathouse, sorry, is that what it's called? The restaurant? The boathouse restaurant? That
Oh,
plaza,
you're
you
back
turn
in
into
there.
that
Oh,
plaza and we're the last building on the end.
okay, like where there used to be a dentist back there. And
Roger Murray used to have an
Roger
office back there.
Murray,
didn't he?
yeah.
Yeah, we're in Roger Murray's old office, if you know Roger, Christine. We're on the second floor, all the way at the end, last building
Okay.
on the right and I'm actually looking out at Back Bay from my
Okay.
window, and there's some really great green filamentous algae bubbling up right now.
Oh, gee.
Well, next time I come, I'll bring a stick.
Yeah, well, I can tell you what it is right now just by looking outside.
I've got another question. Is there a lifespan to algae? I mean, is it, if you see it on, Sunday, is it, you got to think, it'll be, toxic until Friday or something like that? Or
Well, so here's the tough part is the cyanobacteria itself, these colonies, so this one has 5,000 colonies. If they keep having the same situation, that particular colony may die, but the conditions may be right for more colonies to be created, which is what leads to a bloom. And then the organism itself is carrying the microcystins or the anatoxin in it, microcystis or anatoxin, which are the two toxins that we know about at this juncture. They're inside the cells. So when the cell dies, it's released into the water. So it's not safe, actually, potentially for a few days after a bloom, because that's when the toxins are most likely to be released.
okay.
So if you see a bloom and you know the whole lake's under a bloom, that's why they give it the certain period of time for everything to settle down. And then the other thing I didn't mention to you was lake foam. Have you ever seen that lake foam in the late summer that kind of looks like somebody's been washing their laundry in the lake? Hopefully they are not. That's very bad. Don't do that. Please. But But the lake foam is actually it's a conglomerate of all the died off cells of could be any type of vegetation, usually planktonic, but often cyanobacteria, that all those kind of empty cells are washing up on the shore and they create a foam. And so do not let the grandchildren, I know everybody likes to make Santa beards with it. Don't do that.
Oh.
Mm.
So
But
for a lake the size of Winnipesaukee, would there be a whole lake watch or warning issued?
no, not unless it's totally lake wide. So Lake Winnipesaukee, because of its general size and how conditions move, and there's kind of a lot of obvious subsections of Lake Winnipesaukee. So if
Yeah.
you're in 19 Mile Bay, for example, if they've had 2 reports, they may put a warning out on Lake Winnipesaukee. One of the issues we had, in 19 Mile Bay, and then they may put out a watch for the whole lake. Hey, pay attention, but there's a warning in 19 Mile Bay. They
Okay.
may do the same thing for Jockey Cove because of the way the wind blows and certain sections and depths of the water. They've kind of segmented it. But Lake Wentworth is 2 miles by 4 miles. And so because of that parameter, they would put a warning or a watch over the whole lake, which was frustrating because we all want to recreate. We don't want to lose recreation days, but we want to be safe. And so they're jockeying around how are they going to say where it was and what it is.
Okay. Thank you.
Yeah. Does anybody else have questions for me? Well, I hope that we don't have these. We've had so far, fingers crossed, a pretty good summer. I know Gliotrichia is currently present, but not in big numbers and all the water bodies. I've been swimming recently. Just keep an eye out for it. And if you see something, say something. Sorry, I had to do it. But if you do the reports, because it's going to take all of us to watch out for each other and to educate each other. And if you are questioning it, do that stick test, check the Healthy Swimmer Mapper, do a bloom report form, and if you have a sample that looks really fishy, not actually with fish to be clear, please go ahead and scoop it up. And Lake Winnipesaukee folks, I do want to give credit to our very important partners at Lake Winnipesaukee Association, my friend and colleague Bree Rosigner designed the beginning part of this slideshow presentation on behalf of Lake Winnipesaukee Association, shared it with me. I modified it for our lakes because we all do the same work and there's only so many staff and we share everything, but I want to make sure that Lake Winnipesaukee Association, or Alliance now, they've changed their name, gets credit for the work of Bree.
Okay.
Join your association. We're doing lots of good work. Thank you so much for your time. If you have further questions, you know where to find us.
I'll be contacting you by email.
Oh, thank you. I look forward to it, Skip. Thanks, everybody. Have a great night.
Thank you.
Thank
for the
you.
information.
All right. Bye.
Thank you. Great presentation.
Thank you. Bye.
Thank you.
Bye-bye.
Bye-bye.